Good morning, boys and girls, and welcome back to the southern wing of the Stinkbug Works. I haven't been around for a while because I'm waiting for parts, and I've been out doing perk tests. And I've got to go out and do perk tests again tomorrow and the following day. So I won't be around for another couple of days. So just want to let you guys know that I'm still alive and well. Anyway, I've been thinking about this. As you know, with anything like this, you got to think it out before you do it. You know, you got to plan. I like my batteries down low in the sponsons. I know a lot of guys put them up on the top of the tunnel, but if I have my preference, I like them down in the sponsons, which is where I'm going to put these batteries because I can. And since I'm doing a gearbox on this thing, the motor, by definition, is going to have to be on one side of the drive shaft. So follow me on this, if you will. This is what I'm going to make one of these out of carbon fiber. Now that I have a DRO, I can get coordinates on all these holes. I can do 3 holes here, a hole here, a hole here, and a hole here, and then cut out all this. So that'll make doing this real easy. I can just go to those coordinates and start drilling. So I'll have, what'll I have? 1, 2, 3, 4, 5, 6 sets of coordinates. Won't be difficult at all. So the plan is the motor will bolt here, and I have a smile cut here so that I can move the motor a little bit, and that way I can vary a tooth or two on the drives. So I'm going to use right now a 29 and a 40. At the exact same spacing, I could do a 28 and a 41 or a 30 and a 39. Every tooth, if you subtract a tooth from this one and you add it to that one, the spacing will stay the same. Interesting the way that works out. And you see, I have this kind of tall shelf on here. So the motor and the shaft are going to go into that thing like this, and then the motor will have that little bit of adjustment. And it's going to have to be tilted up that way to get the angle of dangle to get the prop shaft out of the bottom of the hull. So that's why I have this up here. Now, this is heavy. If I'm hanging on to just this shaft when I mount it, this heavy motor bouncing around can move this shaft. So I have to have a solid way of mounting this thing. And because I want the whole gearbox to come out real easily with the motor in it, so I don't have to fool around hooking up these darn screws, I want to do that out here and then drop the adjusted unit into the boat. So what I'm going to do is this edge here is going to sit flat on the bottom of the hull. And somewhere along the line, I'm going to take something like this carbon fiber angle and epoxy it there. And I'll drill a hole here that I can bolt this motor down so I can have, I'm going to use clamps to hold this tube in place. And then if I use this bit of carbon fiber angle, it'll support the motor, and I won't be putting any rotational loads on that. It'll all be taken up by this little bracket holding the motor up. So that's my plan for that. I do not have flanged bearings, so I'm going to make a little sleeve that goes inside the pipe, the tube, push it in the depth of the bearing, and then the shaft that goes through the bearing, I'll make another little tiny thing like this, except it'll be a 5mm shaft, and this will be a little piece of K&S aluminum tubing, and I'll just make it, I can make it real thin. I can make it a 32nd of an inch thin, just a little spacer that'll go onto the center hub of the bearing and not touch anything else. So that's how I'm going to retain the bearings. There will be a gear on this end and a coupler on that end, and then those two little shims that I just spoke about, and that'll hold the bearings in place. So that's how I'm going to make a gear drive. I found some gears that I'll give a try. They're steel gears. God, I'm going to have a bit of rotating mass here, but I guess it will be okay. It'll be okay. It's not that much. So I'm going to use steel gears, and like I said, a 29 and a 40, and that will give this the apparent RPM per volt of somewhere around 3,900. So it'll be close to 4,000 RPM per volt, which is a little more usable on 2S. Let's see, 8 times 4 is 32,000 RPM. That's about right for the correct size prop for this boat. I mean, you go too big on props and the prop will stand still and the boat will spin. You know what I'm saying? So there's an optimum size prop. Too small and it's just going to cavitate. See what I originally planned, I had a 0.150 cable that was 3/16 and stepped down for 1/8 inch props. I can still use that because it'll be a drop-in replacement for what's in here now. And what's in here now is just a 3/16 shaft and a 3/16 prop. So I'm going to run 3/16 props, and I'm thinking in the neighborhood of 40 millimeters, give or take, 5 millimeters bigger and 3 millimeters smaller. That will be my range. But 40 millimeters is about the right size for a prop on a boat like this. So I have material to cut out these plates. I have material for the boom tube, the kaboom tube. And I even have the bearings. Now get a load of these bearings. When you go to Boca Bearings and you buy bearings, you normally get them in, a little Ziploc bag. There'll be a bunch of bearings down here in a bag. You're getting the special deal. You're getting the special deal when each individual bearing comes in its own little box. This box costs more than most of the bearings I normally run. Anyway, here's some thinking too. The motor has to now sit on this side of the drive shaft, and it'll have this cool little bit of carbon fiber holding it down there, and it'll be held down here so it's not going anywhere. So I've got this thing in the bottom of the hull at an angle. Well, that does kind of throw off your weight. Now, in a boat set up to go in ovals, and especially with a hydro, it wouldn't hurt to have a little weight on the inside, but here's what I'm going to do. I'm just going to put this, which is pretty close to the same, as that. And what it does is several things. It allows real clean wiring. And the battery's up here, so, you know, the battery will be clean. This will be clean. And it'll allow for a nice compact cooling run. I'll go have a pickup that gazinta, gazada, gazinta, gazada, gazinta, gazada, and probably comes straight back out the bag. We'll see. You know, a lot of guys like those bolt-on water outlets. I'm still old school. I like a piece of tubing that you can slide your flexible tubing over, and you just have a little piece of tubing coming out. Or sometimes, like I did on the Ferrari, just sand it flush. I do that a lot on hydroplanes right in this non-trip a lot. I'll have the exit and an outlet, and I put it on this side because that's the side you generally see if you're running right-hand circles. You'll see this non-trip as it goes by, and you can always see if water's coming out. Don't know what else I have to tell you. That's pretty much it. I've got the DRO on the mill, so I told you I could now just, how nice, I can just plot coordinates and go to them and get it within 1,000th. Actually, this is good to 2,000ths, but okay, I can get it within 2,000ths. That's close enough for model boat work. So I'll be styling with this. Anyway, that pretty much sums it up. Until next time, boys and girls, jet out.